In this video we will show you the Labtrek apparatus to study Peltier effect, Seebeck effect, and their application to study some properties and phase transition in common liquids. By way of example, we will analyze the properties of distilled water, using the Labtrek apparatus. Using a syringe, insert 10 ml of distilled water into the aluminum tray. It is important to respect the indicated quantity to prevent water from escaping due to volume variations due to freezing. On the front panel, using the switches, it is possible to set the operating mode and the quantity shown on the display. The Peltier cells are powered with the run-stop switch. With heat-cool we can set the cooling or heating mode. The Peltier Seebeck switch allows to carry out measurements and study, alternatively, the two physical phenomena. The LCD display shows the voltage across the Peltier cell, or the current. With these two measures, it is easy to calculate the electrical power supplied, and evaluate the efficiency of the refrigerating system. By adjusting the voltage, it is possible to make a transformation, slow enough, to be able to see the supercooling phenomenon. Labtrek provides software that allows you to measure in real time the water temperature, the temperature of the refrigeration system, the electrical power. The red line is the trend of the tray temperature. The blue line is the trend of the water temperature. As you can see, the speed at which the tray cools is much higher than the speed at which the water cools. When the water reaches a temperature of 4 degrees centigrade, a change in behavior is seen. In this graph, we can clearly see all the properties of water. If we look at the blue curve, the one relating to the water temperature, we can see that at 4 degrees Celsius, the concavity changes. As we know, the density of water is maximum at 4 degrees Celsius. The cooling continues, but, as we can see, the water reaches a temperature below 0 degrees Celsius, remaining in liquid form. If we had a phase transition, in fact, we would have a constant temperature trend for a certain time. If the transformation is done slowly, we can reach temperatures of several degrees below zero. As we see later, suddenly the water releases energy and the phase transition occurs. We have a rise in temperature that becomes 0 degrees Celsius and remains so until all the water has solidified, becoming ice. Even if the tank temperature drops, we see that the water temperature remains constant. When the solidification process is complete, the ice temperature begins to drop and the temperature curves of the tray and the ice proceed parallel. If we reverse the Peltier cycle and switch to heating mode, we see that the temperature of the tray rises rapidly, while the temperature of the ice rises up to 0 degrees Celsius to remain until the complete melting of the ice. Students can see in real time what happens to the liquid in the tank and compare their observations with the measurements made by the sensor. The collected data can be saved for subsequent analysis. You can use different liquids or mixtures and compare the measurements. Labtrek has been carrying out original experiments since 2004 to improve the understanding of physical phenomena, helping teachers to show even complex phenomena in a simple and repeatable way. For more information visit our website www.labtrek.it, or contact us for special requests. Thanks for watching.